Now, in this lecture, we shall study the bonding in three-membered heterocycles. Bonding in saturated three-membered heterocycles is similar to that in cyclopropane because these are formally derived by replacing CH2 group by heteroatom. The orbitals associated with the ring bonds are not sp3 hybridized but have greater p character and are considered to be sp4 sp5 hybridized. These orbitals are directed outside the axis joining the nuclei of the ring atoms and involve oblique overlapping resulting in the formation of bent or banana bond. The change in the hybridization of orbitals forming ring bonds is balanced by the increasing s character of the hybrid orbitals forming external bonds. Thus, the internal bond angles in the saturated three-membered heterocycle, similar to cyclopropane, reflect more p character than in sp3 hybrid orbitals, and this is compensated by the external bond orbitals having greater s character and less p character than the normal sp3 hybrid orbitals. The increase in the p character of the hybrid orbitals forming ring bonds result in much less distortion in the interorbital angle than in the internuclear angle, and the bond angle is reduced from 199 degree 28 minute to 106 degree to form banana shaped bonds. Now, the bonding system in three-membered heterocycle can be considered to be constructed from the interaction of pi and pi antibonding orbitals of two structural groups, uh, basal group and apical group. You can see from figure 3 and 4. Basal group is consisting of carbon-carbon bond while heteroatom forms apical group. The basal group carbon-carbon bond behaving as C double bond C bond in three-membered rings forms pi complex with an apical group involving electron donation from the filled olefinic pi orbitals to the unfilled orbitals of apical group. This electron donation in turn is balanced by the electron donation in the reverse direction. Apical group acceptor in pi complex has filled p orbitals that can be used to form a reverse dative bond in which pi antibonding orbital of olefin basal group acts as acceptor. Three-membered saturated rings can be considered as pi complexes with back coordination in which the basal group and acceptor are doubly linked by two opposite dative bonds. The saturated three-membered heterocycle involves two types of interactions. First, interactions involving transfer of electron density from the ethylene fragment to the heteroatom, pi orbital of ethylene with unfilled orbital on heteroatom. Second, interactions involving transfer of the electron from the heteroatom to the ethylene fragment, pi antibonding orbital of ethylene with filled orbital on heteroatom. If heteroatom is extremely electronegative, the second type of interactions are negligible and first type of interactions dominate. The distribution of the electrons in the ring are determined by the relative strength of both the interactions. Now you can see figure 3 and 4 showing bonding system in three-membered saturated heterocycles, pi complex with back coordination.